Right, okay, so DB3, it wants you to set up a DB3 document in a blank word process document. So that's over here. So let's just go ahead and quickly do that. Remember how to go ahead and do your footer. So you can just select footer and just, select blank, and then you can just go ahead and type task DB3, followed by your name and everything else that it wants you to do. Okay, and then it wants you to save the task as, the file as task DB3. Again, make sure you are doing that in that order, just in case, things crash and, you've lost your work or whatever. Just make sure you are doing it as and when you are being asked. Okay, right. The image below shows a relationship between the tables in the database. Right, so you've got the history table in the center, and you've got coastal walk on one side and walker on the other side. So the walker table, contains all the information about the walkers, and the coastal walk table contains all the information about the actual walks. We can see here we've got a relationship being formed from coastal walk ID to the coastal walk ID field in the history table. Yeah, so we've got the primary key field here linking to this field here, which has the exact same name, and it is the exact same field, but it's as a primary key. And then you've got something similar going on this side here. You've got Walker ID, which is a primary key of the Walker table, being used as a key, as a field in the history table. So we call it here, we call this a foreign key. So any field that is in a table, which is a primary key in another table, is known as foreign key. So this history table has the history ID as its primary key, and then it also has two fields which happen to be foreign keys. And these are used to create relationships. Okay, so you've got here the one-to-many signage. So this is saying that one walker can have many history records, but each individual history record can only have one walker ID. And the same thing is happening on this side, or that this is the same meaning. So one coastal walk, one walk can have many entries in the history table. So it can be, be a part of many walks. But each individual record in the history table can only have one coastal walk ID, which makes sense. Okay, anyway, let's move on and answer these questions. So it says here, explain why the walker ID field is required both in the walker and in the history tables. Okay, so the walker ID is here in the walker table and again here in the history table. So it's asking you to explain for 2 marks why it's required in both tables. Okay, so here in your document, you would have part A, and then this is part 1 of part A, and here is where you simply explain that this field is required so that a relationship can be set up. So you can there are a couple of ways you can say this, but one way is so if I just go ahead and type in the field name exactly as it is, there we go. So Walker ID is a foreign, can't spell today, goodness me, foreign key in the history table. And a primary key, primary in the walker table to identify the walker in the walker table. Let me give that a capital W. This is the name of the table. And therefore having the tables linked, or something, however you want to say it. So walker ID is a foreign key in the history table and a primary key in the walker table to identify the walker in the walker table, and therefore having the tables linked. Whichever way around you want to say it. It is to link the table so that the walker can be identified by the ID, whichever way you want to say it. Just make sure you fully explained it, and then you'll get like the marks for that. Okay, what does part 2 want? Explain why it is better to store the data in 3 tables rather than just one big table. Okay, so why have we got 3 separate tables rather than 1 table? So again, you get a couple of marks for giving good reasons as to why it's better to store data in 3 tables rather than just one. One thing you can say is that there is no redundancy. So obviously, if you think about it, if you had if you had multiple walks happening, as you do in a history table, that's recording the multiple walks happening. Let me actually load up the table so you can see. Here we go, history table. So you've got multiple walks happening, and you can see here that who's repeating, who's going on multiple. Here we go. So 106, Walker 106 has gone on a couple of walks. So that would mean that we would need to repeat their names twice, their surname twice, the date of birth twice. So it's just extra data being added. Same with the coastal walk itself. So the walk number 1 there, again, 3rd time it's appearing here. So we would have to repeat that information 3 times because that has appeared 3 times in the history table. Or it took place 3 times. That walk took place 3 times. So that's what we mean by redundant data. You're repeating data that really shouldn't be or needs to be repeated, or there must be a more efficient way of dealing with this. So no redundancy of data is one reason why we have 3 separate tables, or we separate data into different tables rather than having it all in one table. So that's one thing you can say. Another thing you can say is that the data is grouped. So, for example, you have Walker information, and that's anything to do with Walker is just in the Walker table. And then you have the walk information, the coastal walk information, the actual walk itself, how long is it, where is it, and so on. So that is separately grouped into the coastal walk table. So data is grouped. So in items belonging to a specific thing just stays in that table. So that's another thing you can say. And let me just put on. Yeah, I won't put an or because you should give 2. Should you give 2 points? It's worth 2 marks. What does it say in the mark scheme? In the mark scheme, it says award 1 mark each, up to a maximum of 2 for explanation, including. Okay, yeah. So it will be good to say a couple of things. So you say 2 things here, but just make sure you've said a full sentence for it. Okay. Another thing you can say is that. Changes only need to be made. Changes only need to be made once or in one table. So, for example, if I want to change the I don't know, the surname of one of the walkers, they've got married and they've changed their surname. I only need to update it here in this table. So because the history table, it's already linked to the Walker table via the Walker ID field, if I wanted to know the name of the Walker ID, I could just, easily call that because it's linked to this table. But I only need to have updated it once here, and then this will be able to access the updated name. So you can imagine if all the information was in one table, like I was showing you here, to say if you just imagine that you've got, the same person's name repeating. So who's 106? Let's see 106. Who are you? 106. Oh, it's in a funny order. Here we go. This person, Thomas Lee. So Thomas Lee, I'd have to repeat the changes here. So Thomas Lee would have to be changed in one row, then again in another row, and then if he took another walk somewhere further down in this history table, or in this one big table which had all the information in it, I'd have to change their name in multiple places. So that wouldn't be very efficient. That would be time consuming and so on, and then it could even lead to errors and so on. So yeah, so changes only need to be made once or in one table is another reason for why it's better to store the data in 3 tables. Rather than in just one. Okay. Yeah, so they are enough reasons for you to give. So I would say you'd have to give 2. Go ahead and give 2, just in case you haven't properly explained one, or you've just you've not explained it further enough, or it's not clear to the examiner that you really understand why. Okay, so that's that. Right. Anyway, resave task DB3. Save. Done. Moving on. Part B, Leonie wants a list of walkers who have completed either the Anglesey walk or the Durham walk. Okay, right. So what data do we need? Show only the fields first name, last name, birthday, walk name, all of these, and have some sort happening. And we're going to do a query for this. Okay, fine. So let me just close everything. When you're making a query, you've got to close all the tables at least. Otherwise, it doesn't work properly, or it doesn't work at all. Okay, query design. Let's go ahead with query design. What tables do we need? So first name, last name, well, that's obviously come from the Walker table. We've got walk date and walk time. Well, that's something from the history table. Walk name is in the coastal walk table, so we need all the tables. Okay, lovely. We need all the tables. It's all right, to be honest with you. Even if you don't need all the tables, you can still add them all and then just pick whatever fields you actually need. Okay, why is it so hard to grab? There we go. Lovely. Okay, so show only the fields, first name, surname, and so on and so on and so on. It wants it in this order, right? Let's go. First name, and that's here. First name, last name, birth date, walk name, walk date, here, walk time. Lovely. It also has said that Leonie only wants a list of walkers who have completed either the Anglesey walk or the Durham walk. Let's have a double check of the coastal walk table. So that's the walk name. No, it's not. Oh, it's not even here. Where is it? Where is the Anglesey walk? So that would be in coastal walk. Oh, silly me. Couldn't even see it. It's right there. Walk name. All right, so we're going to specify criteria by walk name. Okay, fine. So walk name here is going to have criteria specified for it because currently it's going to be showing lots of records, which we probably don't want. So let's go ahead and specify the names of the walks. So the first one was Anglesey. So yes, it was entered as capitals, but remember it doesn't matter if you do it uppercase, lowercase, just get the spelling right. Data type mismatch in criteria expression. What happened? Walk name, criteria, Anglesey, yes, and Durham, yes. Oh, sorry. Oh, it's good I did this because look, I'm putting it in the wrong column. It should be in walk name. It should be in walk name. Okay, so let me just send that along over there and then do the same for this. Oh God, here we go. Okay, good. Right, next, lovely. Okay, that's done. So let's just double check. Show only the fields first name, last name, birth date, walk name, walk date, and walk time. Okay, right, that's done. And it should be sorted in ascending order of walk date within ascending order of walk name. So remember the word within is key here. Whatever comes after it, that's what has to be done first. So ascending order of walk name first and then walk date. Okay. Walk name first and then walk date. Right. So there's walk name. So we sort this, make sure it's sorted in ascending order. And then walk date is sorted in ascending order. There we go. So yeah, walk name is in ascending order and walk date is in ascending order within that. That makes sense, right? Yes, so we've got March, September for these. Lovely. And then we've got February, August for Durham. Yes. Okay, lovely. That's done. Display the results. Save the query as DB3. Right, let's go ahead. Save as DB3. Let me do it exactly as it wanted. Is this part A or part B or anything? DB3, no, just DB3. Okay. Copy the results. Copy the results of your query into DB3. Okay, fine. So select all like this. Copy. DB3 is waiting. Here we go. Lovely. Okay, that is fine. But remember, if you feel like it needs to be made a bit clearer, then go ahead and do that. It doesn't take more than 20-30 seconds. There we go. Lovely. Okay, done, and then we resave like that. Okay, and that is the end of task DB3. So for all of that, you get 9 marks for all of this. Okay, so just doing the query on its own gives you 5 marks. So just make sure you get it right. Okay, next video is going to go through task DB4.